Grasshopper. So, for example, now we will learn how to do this kind of models in a really simple way. Okay? Actually, it's not going to be a pentagon, it's going to be whatever shape you want to do, as many faces. Because why? We will do it parametric. We will do a 2D parametric modeling. So let's try to debug this, and let's come back to the history and how we can do this. What is the logic of this geometry? Yes.
What do you mean by that?
How is the logic of this geometry creation? Could be actually the logic of this, how you make this, it could be done in multiple different ways. Is how you find the logic. The logics of Grasshopper scripts or any parametric scripts will depend on how you build it. You can build it, for example, this will start as a, this is a 3D model, is we put a polygon of X amount of faces in an origin, okay? Or we can place an origin and we can put a line with this shape and we do a polar array and we do the intersection. It's another logic. In my thoughts, like the easiest one is we place a polygon, X number of faces on an origin, and we will do a rectangle that we will place at a certain distance from the origin, and we will do an array and we will subtract. Another logic could be we have a polygon, we find the discontinuity on the polygon, it means the corners, and we place rectangles based on the vector between the discontinued and the origin. So actually it's got also a line. And we can do the same with, if this is a line, we deconstruct the polygon, we explode it into lines, so we got one line, one line, one line, and we find also the midpoint of the line to place also the rectangle. So actually there are 3 different logics for this silly thing. Let's see how we can do this. Let's go with one of the, for me, will be my choice, I think. So I will place a polygon. Polygon. Yeah, this is just for completely parameterizing this. I just place a polygon. I'm going to put a component that is a plugin that's called bifocus that will put the names on top of the component. Okay. So the polygon asks for the location, is in origin, so it's perfect. The radius of the polygon, let's make it bigger, 10, or let's make it even bigger, 500. 10 centimeters, let's make it 10 centimeters. Okay, how many segments? We want to go from 0 to 10, I don't know, or let's put 12 and let's reduce. For example, wow, amazing. Let's reduce it to 6. Okay? Yes? Do we want to fill it the radius? Right now, no, we don't want it. Okay, we got the polygon. What we can do is, for example, we can find what we can do. We can explode the polygon. Explode. What happened? So we can, this is a line, no? This is a polyline curve. We can explode it. If we explode it, what we have? The vertices and segments. 6 lines, no? What we can do? Right now we have the vertices, but let's only put notches on the midpoint. So let's go a slightly more difficult. So if we got the segments, I would put a panel so we remember that we have the segments. How we find the midpoint of the curve? Let's go to curve components and let's analyze them. So in analyze, you have endpoints, polygon center, or we have what is called curve evaluate. What is curve evaluate? We want to analyze the construction of the curve. So we want to analyze the curve. And what is the parameter t? Okay, this is one of the most important concepts of Grasshopper and these are the evaluation components. That is, we want to check how this line is at a certain point. We want to see the properties of the point, one point of the line in the line. The curve has a parameter. What is a parameter? It means in which position do you want to evaluate? Do you want to evaluate the curve here, 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 here? How we can know? By the length, no? A curve, whatever line, has an origin that is 0 and has the total length that is x, no? If we want to measure at the midpoint, what is? X by 2. So do we need to measure the total length of each one of the curves? This, it will be, we can do it, but it will be really annoying because we need to measure the distance and then put this value here. We want to evaluate the curve in the x2. So we have a component that is reparametrize. If you right click on the curve, you have something that's called reparametrize. It means I don't care if your length is 100, 200, 300. For me, I will associate 0 and 1. 1 will be your maximum length, 0 will be your initial length. So by doing so, evaluating at the start of the curve will be 0, at the middle of the curve will be 0.5, and at the end of the curve will be 1. Let's see it. We are doing it with 6 lines at the same time. Let's only take one line and see it. Don't use this component. This is just for previsualization, so I can show you. List, item. And let's hide this. So if we have this line, right now we are analyzing the line at the start and at the end of the curve. We just find the midpoint of the curve. And this is how we analyze not only curves, but complex surfaces. We can have a surface like this, and we want to find the midpoint center. What we do is reparametrize the surface and find the point in the surface. Surfaces are bidimensional. So we need to set up, instead of a 0.5, is 0.5, 0.5, a bidimensional point. And actually, we do this with curves, lines, surfaces, meshes, three-dimensional objects, with everything. It's about measuring and getting properties of certain points on elements. So we just got the midpoint. Let's connect it and see the other ones. Oh, let's show. Okay. So right now, we got the midpoints. We see also the vertices. We can use it or not use it. What I can do is, just for now, we can hide this preview and just show the polygon. Right click, preview to show. Okay, so we just found the midpoints. That's good. So what we can do now, we can put a rectangle, center rectangle. Let's go for curve, primitives. For example, rectangle, rectangle 3 points, polygon. What is the position of the rectangle? We can see it is the origin here. Let's first create the rectangle. The size is a size that goes from -1 to 1. No? This is the size of the rectangle. -1 to 1, -2 to 2. That's why it's a rectangle like that. So if we want to build a domain, it means from where to where dimensions go. The rectangle could be just, for example, 50. If you just set up 50, the domain will be from 0 to 50. Automatically assume it's 0. So actually, that's why it's like that. What happens if we want to center the rectangle? It will be -50 to 50, no? So we get center rectangle. Why we want to find the center? Because if we associate here a rectangle, it will not be exactly in the center. What we want is that the rectangle is in the center so we can subtract it. So we need to create a domain. A domain. Domain. I will look for the component for you. Domain. That is maths. Construct domain. So is. Let's erase this. Is, for example, from 10, and I could just put a negative. Negative. So from -10 to 10. And I can connect to y. So right now, well, this slider is small, so I will make one big. So I can easily modify the length of my rectangle, and I can do the same for the axis y. So now I have a really parametric press fit. Remember that, for example, right now, this is 10. It means if it's 5, actually the width is 10. We are duplicating. It's something that we need to remember. Is half thickness of the material. We can just type names so we can remember what the slider does. We have created the rectangle. What we need to put the rectangle in place? We need to locate the rectangle in here. How we can create rectangles? By placing them on planes. Right now it's located in this plane. If we just connect the points to planes, this happens. We have the rectangles in place, but they don't have the proper orientation. Why? Because the plane is the same, it's XY, standard and standard XY plane. We need to build planes based on the radius, on the radial. So it's a plane that is XY for this one, a plane that is like this, a plane for it that is like that, a plane like this that is like that, and a plane that is like that. So they are oriented. This is way easier than actually understanding the domain logics. So what we do is we construct a plane. We're gonna make the planes based on what? First is the origin, where the plane is located. Okay, we have create some planes, and a plane is done by what? Two vectors. Both vectors are gonna be perpendicular always. So we just need to state one of the vectors. How we can create the vectors? A vector is created by one point and another point. Just with these 2 points, we have already the vectors. So what we do is we're going to create vector 2 points because we have these 2 points. We have point A and point B. What is the point B? Is the origin of everything, no? It's origin. We can also create the tangent. Yeah, that's true. Yeah, way easier. Sorry. Like you see, sometimes it's like there are shortcuts somewhere and you don't realize. Yeah. But the tangent, for the ones that don't, is like doing exactly the same. So constructing the point, This and this does the same. The difference is here we just made it, and here it was here. So instead of constructing with the tangent, we just state planes, and we have it. This we can switch it off, and we have our vectors aligned. Let's hide it. Okay, so we have the rectangles that we can easily change the thickness, and also what's happening. Everything adapts together and updates really well. What we can do? You know why? Why now we can create? Do we want this? Because what happens if we want to also put in the vertices? I just got lucky. Vertices. We don't have the tangent, so we can create the tangent like this. We, instead of using the points, these points, the midpoints, let's use these vertices. We have created the vectors, and we do the same. The vector is this one, but the origin is the segment, the vertices, these vertices, this one. We are creating the vectors for these ones now. And what we can do is connect both together. And you see they are in a different orientations. So what we can do is, instead of connecting to x-axis, we connect to y-axis. And no, it's not working. Why? Let's see. Coordinate from here to here, point A, point B. Let's do a vector display to see the vectors. What is a vector and where it's located? Yeah, so what we can do is, for example, introduce a plane rotation. We can rotate it, or we can create a perpendicular vector. I don't remember if it is perpendicular vector. Or rotate. We want to rotate this plane, for example, geometry to rotate. What is the plane of rotation? Their own. And we want to rotate how much? 90 degrees. Grasshopper has something that is really annoying, works in radians. But we have a component that is called radians to radians that transforms to degree to radians. And we introduce 90 degrees rotations. And let's connect this one instead of this one. And we have it. So now we can hide everything and only hide the original polygon. And we have the geometry that we can make a subtraction, for example, or we can create a surface. This is in transform in here, intersection, shape, region, difference between these curves and the original polygon. Measure up. This is the measure. We have it here. This is the radius of the polygon.
Yeah, but to know what size is the polygon or what size is the
You mean analyze the polygon? This is the size of the polygon. You have it here. It's double of this.
Okay.
You want to measure? You mean?
I want to have like to preview everything on the same place instead of going.
No. What you can do is analyze. Wait, why we cannot clear all drawings? Yeah. What we can do is, this is a curve. We can always go back and analyze, and for example, analyze the total, the boundary, the area, make a bounding box and measure the bounding box. So that's all the tools like surfaces, curves. What they always have first is analyze, because with analyze is first how you create geometries and then how you keep control of the geometry. For example, as you said. Or for example, for that one will be, we can measure the total length of the curve. If you want to measure the length of the curve and you want to calculate the time it will take to cut at 30 millimeters per second, it will take to cut like 1 minute, for example. And analyze, for example, we can get the dimensions. If this was a surface, it's not a surface, but we can do is like make it a surface. How it's called is patch a surface. Oh my God, I'm super sleepy today, sorry. For example, we can patch the surface and analyze the surface, and we get the dimensions in UV. So with this, we can easily modify our geometry. We can activate or deactivate things. So it's all start analyzing your surfaces. I will keep it here for a few seconds so you can actually see it. You do see it a little bit, no? I cannot, I will try to compact it a little bit. This we can take it out, this we can take it out, and this one we can move it here. This one we can move it up, so it's slightly clear. Yes. Yeah. Like you see, when I said you select them, this menu shows up. Align to the left, to the top, keep the spacing.
But I would like, for example,
You select them, right click, center click, and group. And you can then right click and change the color of the groups. This will be one thing, and this will be analyze. That is a completely different thing. Color. Okay. There are no buzzer questions.
Because the modules that I'm having doesn't look like anything as yours.
They don't look. They don't look, you say?
No, like for example, the polygon, you have like the full text description.
Okay, in display, here you can activate draw icons, draw fancy wires, draw full names. I have everything activated. So draw icons, they.
It's way better. We should go by default.
Last class I had a Grasshopper, they said the opposite.
Really?
Yes, actually I was drawing with icons and they say, please, can you put the names? So right now I just like, whatever the class asks for, I will change it, I don't care.
I guess that in the end, there are different kinds of learning, so I'm very visual.
Yeah, it
The
depends.
icons like say a lot more than the words.
And the plugin for the names that you have.
The lines?
Yeah, you said that you have like a sticker over there.
For these labels.
Yeah.
This is called bifocals.
Okay.
Bifocals. Glasses. Is well usually like is usually in general only the one that is teaching uses it because it's too short the name so everybody follows up. The curve. Curve.
And how do you know that like taking the error because like that, you know, like for 0, 5, for example.
For example, the width of the rectangle is 3. So in order to adapt, okay, this is doing a little bit of mathematics. So what I do is usually like I make a slider from 0 to 10. Okay, this is my thickness of material. Material thickness. I have a curve of, I don't know, 0. Usually is the curve is a really small number. So let's state from 0, 0 to 1. My curve is 0.25, more or less, or slightly smaller. 0.25. Let's state like that. Okay. This is the curve value. So curve, if you have a rectangle, you will cut in 2 sides. See, you have a rectangle. You will have curve here and curve here, but only if you want the internal part, you have half of it. So it means you have 0, 1, 2, and 0, 1, 2 on each side. So in total is 0.25. So what you do is you have a 5 millimeter thickness. You subtract, because you account that you are losing only half of it, but you have 2 sides. So this is actually the total of your material, taking into account that you will eat 0.25. So when you cut, you actually match again 5. And now you can divide division by half, 0.2, by 2. So this is how you connect the sliders. Instead of connecting this, you connect this. I usually add, if this is the curve, a multiplication of 20%. Like to have error on the material, etc. So I have the curve plus a percentage, and I have. So like this, I have like some sliders that I can easily pick really fast everything. When you have scripts like this done, what you do is you move everything to the beginning with the names. For example, this is the number faces. This is the radius polygon. And we have another one. This is a location of notch. I don't know if it's well spelled. And we have, what else? A rectangle. Remove from group. And this is notch length. So now I can not worry about anything else. And here I can have my, let's say, video game to play with. So really depends. And there's an extra thing that maybe you will like. That is, these sliders, we can publish to Rhino and close Grasshopper. So we right click, publish to remote panel. And number of faces, publish to remote panel. We go here, and in one of these panels, I don't remember which one, I never do this, sorry. I will suppose panels, remote the panel. Notes, no. Display, no. Where is the remote panel? You see that I use every day, no? Maybe here, right click. Just Grasshopper, here. So now I can have Grasshopper hidden and keep playing with the remote panels. from Grasshopper, from Rhino. This you do when you have like really complex scripts that you want to do with visualizations, or you want to do animations, or you want to give, for example, this for a client, and you don't want to make it stress with Grasshopper. So you made everything, you put it in a nice package box of Rhino, and yeah, it's open. Like this is minimized here. Uh-huh.
Do you have any resource or any advice on where to go, like literally parametric for, in the sense that not just Grasshopper, agreeing Grasshopper, but kind of like developing on thinking way?
I can look for some references, but right now I don't remember. I will look for it and send you the links. I have, but right now I didn't take coffee this morning. Sorry. You mean the parametric design ways of thinking, of modeling your brain, no? Whatever depends on the software or not.
Well, because like, at least for me right now, it's not that I'm learning the software, because like learning software following steps, it's easy, there are tutorials, but it's about thinking differently on how to design things in a certain
That's
way.
no, that's the most important thing. For example, Dynamo is the Grasshopper for Fusion for Autodesk. I don't know Dynamo, but I'm pretty sure in 5 minutes I'm able to move around, just because if you understand the logic of how things are built, it's way easier to jump.
Yeah.
Is the most difficult part is this is visual scripting. It's actually parametric thinking and scripting. What do you think? For example, actually having like spending a lot of hours in Grasshopper helped me out a lot in my coding skills, because at the end it's just we are just assembling lines of code, but we are doing visual. I don't remember how to put the commas or the integers, etc. But I know that I need a line of this to follow our set of instructions. Totally agree with what you said. Yeah. We'll look for it, for information, like some books or PDF about it. And as always, I'm late. Xavi. Perdona. Xavi turned on OpenSCAD, that is the same with, but for coding, literally. Instead of doing visually, you will do what coding with OpenSCAD. I will look for it, okay?
Can you Grasshopper?
Yes. But I move all the elements, so let me. But this session is recorded. If I want to replicate, Mayra, what do you mean?
Hola, Eduardo. Si quiero tener más piezas, so I want to get more pieces.
Really good question. Okay. You have this shape, no? You want to have more pieces. Xavi, ya cuando quiera. Vale. You want to, if you want to put pieces around a space, what do you want? Matrix or array? Rectangular array. You put the geometry, and the geometry you need to state the cell size, that is basically the rectangle, that it will keep the shapes in place. So for example, cell is rectangle. The rectangle is going to state the dimensions of the space in between the parts. So for example, 500. Let's just take a simple rectangle.
And if you want to change some of them,
if you want to change some of them,
for example, you want one to be a rectangle or a square, other one to be circle.
In that case, what you need to fit is different numbers here, and that is one of the strongest point of Grasshopper. This is the basic sketch, so what you can do is copy this 20 times, or on the opposite is fit different radius. So actually, right now we have two shapes together in the initial one, but you see that here we have two polylines, and the lines become more messy. because we have two branches of code working at the same time. Actually, that's one of the strongest points, and is how you could create like 20 types of models with different tolerances and just have little differences. But I didn't want to mess too much with that because it's called branching. It needs a little bit more experience.
And then we can move the positions of each piece, or it's not possible, because if I want to organize the pieces.
Nesting. I will export this. There is a nest here because I have a plugin, I think, or no, maybe. No, I don't have the plugin installed. There's a plugin for nesting in Grasshopper, but I will export this, use deep nest, way faster. Like sincerely, way faster.
Okay.
And way better. For example, you can just export one of the rectangles and multiply it in next. I have like 200 units of this, and will automatically make the copies. So you don't need to make this like the copy thing. Actually, for example, let's do it. Xavi's gonna kill me. Xavi's gonna kill me. Export selected. SVG. We cannot export to SVG, so I need to export it to. ¿Dónde está? Ah, aquí. Uno. Okay, save. Ah, that's true. And we need to export from the top view because it's an SVG. In top view, like it basically exports what you see. I will try. I never export from Grasshopper SVGs. Deep nest. Vamos. Import. It's empty. You probably will need to jump to Illustrator to clean the SVG or something. Sorry, like usually keep everything into Grasshopper environment and do everything there automatically. A ver, Illustrator, se abre. It's a SVG. Let's export it or save it again. It's not export, is file save as SVG 2. Type SVG, let's go for 101. Convert to outline key, blah, blah, blah. Okay. Let's see. So silly, you see? It's just saving again from a different software. So now I have this one, and I can increase the count of units I want. What I did wrong here, I didn't draw the rectangle of my material. I should have a vector of the rectangle of my material. The good point is I can draw it here, for example. I will erase this. This is my rectangle. File, export. It's saved as rec. Okay. And I import. I will add this here. No? Rectangle. Ooh, it's cool. You don't know.
So I can use Inkscape, for example, right?
Yes.
It's the same.
Yes, you can use Inkscape too. And start nesting. And it's nesting.